Welcome to the world of LoRaWAN technology. This presentation will provide you with an overview of LoRaWAN, which stands for Long Range Wide Area Network. It's a technology specifically designed for the Internet of Things, also known as IoT. So, what exactly is LoRaWAN? Firstly, it's a low-power wide area network protocol, often abbreviated as LPWAN. This means it's designed to operate with minimal power consumption over a large area. Secondly, it's specifically tailored for battery-operated devices within IoT networks, ensuring these devices can function for extended periods without needing frequent battery changes. Thirdly, it provides long-range communication, capable of reaching over 10 kilometers in rural settings. Fourthly, LoRaWAN supports bidirectional communication, allowing for data to be sent to and received from end devices. Finally, it ensures secure data transmission through end-to-end encryption. LoRaWAN boasts several key features that make it ideal for IoT applications. Firstly, it has low power consumption, optimized for battery life of up to 10+ years, reducing maintenance. Secondly, it offers long-range coverage, spanning 2 to 5 kilometers in urban areas, and up to 15 kilometers in rural environments. Thirdly, LoRaWAN provides strong security with advanced encryption standard, also known as AES 128 encryption, ensuring end-to-end security with unique network and application keys. Fourthly, it has scalability. A single gateway can support thousands of nodes using a star of stars topology. Fifthly, the adaptive data rate optimizes both power consumption and network capacity. Finally, it allows for bidirectional communication, supporting downlink messages for device configuration and control. The LoRaWAN network architecture comprises several key components working together. First, end devices such as sensors and trackers collect data and transmit it wirelessly. Second, gateways receive these transmissions from the end devices. Gateways forward the data to the network server using an Internet protocol, also known as IP connection. The network server manages the network, handles security, and eliminates redundant packets. Finally, the application server processes the data and makes it available to the end user. The communication between end devices and gateways uses LoRa radio technology. LoRaWAN defines 3 device classes, each optimized for different use cases. Class A devices are bidirectional end devices, enabling uplink transmissions at any time, with downlink communication available only after an uplink. They are the most energy efficient. Class B extends Class A functionality by adding scheduled downlink receive windows, offering a balance between power consumption and responsiveness. Class C devices offer continuous listening, providing the lowest latency for downlink communication, but at the cost of higher power consumption. These are typically mains-powered devices. LoRaWAN operates on different frequency bands, depending on the region. In Europe, the European Union 868 band is used, ranging from 863 to 870 MHz with 8 channels. North America uses the United States 915 band, ranging from 902 to 928 MHz with 64 plus 8 channels. Asia utilizes the Asia 923 band, operating at 923 MHz with 8 channels. Australia uses the Australia 915 band, spanning from 915 to 928 MHz with 64 plus 8 channels. China employs the China 470 band, ranging from 470 to 510 MHz with 96 channels. India utilizes the India 865 band, operating from 865 to 867 MHz with 3 channels. Regional parameters include factors such as maximum transmit power, duty cycle, and data rates, all varying by region. LoRaWAN incorporates multi-layer security features to protect data and devices. End-to-end encryption using Advanced Encryption Standard, or AES 128 secures data from the end device to the application server. Unique network and application keys segregate network operations and application data. The message integrity check ensures that messages haven't been altered during transmission. Frame counters prevent replay attacks by tracking message sequence. Finally, device authentication ensures that each device is uniquely identified and authenticated on the network. The network session key secures network communication. The application session key encrypts the application payload. The application key is used for device activation. LoRaWAN technology enables a wide range of use cases across various industries. In smart cities, it facilitates urban infrastructure monitoring and management, supporting smart street lighting, waste management, and parking space monitoring. In agriculture, LoRaWAN enables precision farming and environmental monitoring through soil moisture monitoring, livestock tracking, and weather stations. For industrial IoT, it supports manufacturing and industrial process monitoring, including equipment monitoring, asset tracking, and supply chain management. In healthcare, LoRaWAN aids in remote patient monitoring and medical asset tracking. Smart buildings leverage LoRaWAN for energy efficiency and security through heating, ventilation, and air conditioning, also known as HVAC monitoring, occupancy detection, and energy consumption tracking. Finally, utilities benefit from smart metering and infrastructure monitoring, enabling smart water metering, gas leak detection, and power grid monitoring. Looking ahead, LoRaWAN is set to evolve with several key trends. LoRaWAN version 1.1 and beyond promises enhanced security features, improved roaming capabilities, and better network management. Satellite integration aims to extend LoRaWAN coverage globally, particularly in remote areas. Energy harvesting will enable self-powered devices using solar, vibration, or thermal energy. Edge computing will bring data processing closer to the source, reducing latency and bandwidth requirements. Finally, geolocation improvements will enhance positioning accuracy without the need for global positioning system, also known as GPS. In conclusion, LoRaWAN offers long-range, low-power connectivity for IoT, making it ideal for battery-operated devices with years of operation. It provides a secure, scalable network architecture with global standardization. A growing ecosystem supports diverse applications across industries, complementing other wireless technologies in the IoT landscape. For further learning, refer to the LoRa Alliance for official specifications, the Things Network for community-driven networks, and the LoRaWAN Academy for educational resources. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.